Hello guys, this is part 2 of equivalent ratios for Math 6. Our learning target for this lesson is to use ratio and rate reasoning to solve real-world and mathematical problems. We will be making tables of equivalent ratios relating quantities with whole number measurements, finding missing values in the tables, and plotting the pairs of values on the coordinate plane. Our sub-skill there is to use tables to compare ratios. Okay, and looking at our first start problem here to get our brains thinking about ratios, the first thing that I want to do is I see I'm presented with 4 different ratios. The best way to get my brain thinking about these numbers is to draw a model to follow each of these. So we're going to have 1 triangle to 3 circles, 3 triangles to 1 circle, 3 triangles to 9 circles, and 9 triangles to 3 circles. So I'm going to go ahead and write those out. And 3 circles. Okay, so now I'm going to look, what are the same and what are different? In thinking about our last assignment, our last lesson, we talked about making equivalent ratios as repeating a set. So I can look at this one as a set. I have 1 triangle for 3 circles. And if I look down here at letter C, I have 1 triangle for 3 circles. And I see that that pattern follows. So this one is an equivalent ratio. So A and C are the same. They are equivalent ratios. Now looking over at B and D, I see that I have 3 triangles for every 1 circle. So that's 1 set. Here I can see 1, 2, 3 sets. So these are also equivalent. So B and D are the same. Okay. Now we're going to look at our first problem. Okay, we have a streaming music channel always plays the same ratio of pop songs to hip hop songs. The point on the graph shows the number of hip hop songs played for every 3 pop songs. Based on the relationship in the graph, how many hip hop songs does the channel play for every 12 pop songs? So the first thing I want to do is I'm going to write a lovely little ratio table. Okay. So I know that what we're comparing is pop to hip hop. And the first value that it gives me is that for every 3 pop songs, I can look over here and it shows me my values here. For every 3 pop songs, I'm going to have 2 hip hop songs. Okay. So now I can go ahead and fill in my table using my knowledge of ratios and how a ratio table works, is I can go ahead and add in the next pieces here. So I know that this is going to be 4 because I'm either adding 2 or multiplying by 2. Then we can do the next thing, either add by 2 and get 6 or multiply this times 3. And then the very last thing, I can either multiply by 4 or add 2 more to get 8. Okay, and the same thing will be true on the opposite side. So I'm going to add 3 or multiply by 2. So 3, 6, 9, and 12. Okay, so now the question is asking me, how many hip hop songs does the channel play for every 12 pop songs? So I can go down here on my 12 on the pop songs and then find that the ratio that would follow with 12 pop songs is 8 hip hop songs. So there we have our answer. Okay, so this is my answer. I have 8 hip hop songs. Okay, the next thing that we're going to do is we are going to graph our values. So if you see here, we already have 3 to 2. Now we're going to use these next ordered pairs to go on a coordinate plane. So we're just going to draw the first coordinate, or first quadrant, sorry, with X being pop and Y being hip hop. Okay, and then I'm going to number my numbers here in blue just so we can see them a little bit better. So we're going to go 2, 4, 6, 8, 10, and then we'll kind of scoot this over a little bit, and 12. And the same here, 2, 4, 6, 8, 10, 12. Okay, so on our first one already is here for us. So we're just going to go ahead and redo that. So these numbers, this is going to be our X and our Y. So this is going to create an ordered pair. So we're going to go over 3, which is about right here, and up 2 to create our first point. Okay, so that's 3, 2. Okay, and then our next one is 6, 4. So we'll go 6, 4. And so on. We'll go 9, 6. And we're kind of getting over into this. Let's do this. We'll give ourselves a little bit of space here. And then we'll look over, and our last one is going to be 12 up to 8. So we'll do 12, 8. Okay, and we can see we're going up 2 here, and we're going up 3 here. So we're moving over 2. So sorry, we're moving over 3 plus 3 and up 2 every time. So we'll see that pattern again. Up 2, over 3. And it's going to keep going on. So just like I showed you in my graph, we're going to add 3 every time on this side, and we'll add 2 every time here. And the same thing is true on our coordinate plane. We're going to go over 3, up 2, over 3, up 2. And if it keeps going on, over 3, up 2, over 3, up 2. All right, so we're just going to go ahead and skip that one. All right, we're going to look at number 8 here. Enrique has a container of 32 fluid ounces of juice, of orange juice. So I'm going to start off by making myself a ratio table where I have fluid ounces. And then it says he's filling glasses with 1 cup. So my other unit here is going to be cup. And I can also see that that's true here, fluid ounces and cups. So he's filling 1 cup of juice for every 8. Sorry, hold on, I'm getting ahead of myself here. Let me finish reading the question. The point on the graph shows the ratio of fluid ounces to cups. Based on this ratio, how many glasses can Enrique fill from the container? Plot a point on the graph to show the number of cups in 32 fluid ounces. So we can see here the first one that they have, it's 8 ounces. For every 1 cup, there's 8 ounces, right? So we can go ahead and fill in the 8 right here. Now what it wants us to get to is 32 fluid ounces. So how many cups of orange juice would I get out of that 32 fluid ounces? Well, let's go ahead and fill in our ratio table, knowing what we know about ratios. So we have 8, 16, 24, 32, and then 1, 2, 3, 4, because remember we're going up plus 1, plus 1, plus 1. Okay. So now that we have our completed ratio table, we can see that there's 32 fluid ounces in here. We have 32 fluid ounces right here. So the corresponding amount of cups is 4. So our ordered pair is going to be 32, 4. So on the fluid ounce side, I'm going to go to 32, and then I'm going to go up to 4 to show the cups. So it'll be right here. 32 and 4. And it's important when you plot your point to give its ordered pair with it and to keep it cozy in those parentheses. Oh, sorry, that should be a 4 here. There we go. Ta-da! All right, every 4-ounce serving of Yum's yogurt contains 8 grams of protein. Complete the table of equivalent ratios, then plot the points on the graph to represent the ratios. So here we can see it's going up by 4, right? Plus 4, plus 4. So I would know that it says every 4-ounce serving of Yum's yogurt contains 8 grams of protein. So that means 4 ounces for 8 grams. Okay, so I can go ahead and continue filling in. I'm going to use a different marker, sorry. I'm going to go ahead and continue filling those in. So if I have 4 to 8, I'm going to have 8 to 16. Because remember, we're adding 8 or multiplying by 2. This one I can see is going up times 3. So then 8 times 3 right here would be 24. Okay. Now I can see, oops. So I can see if this is 32, my equivalent ratio would make this one, if I did this times 4, then it means I'm going to do this one times 4 as well to get 16. So my ordered pairs are all on there now. So I can go ahead and plot my points. So it says plot points on the graph to represent the ratios. So I can see that this one is the same as 4, 8, 8, 16, 12, 24, and 16, 32. Those are my ordered pairs that I'm going to be plotting. So I'll go ahead and start off with 4. The other thing to notice here is that how these are laid out. So this is going by 4s. So 4, 8, 12, 16, 20, 24. Okay, that way we can have more space here. This one is also going up by 4s. 4, 8. Okay, so keep that in mind. So we have 4 to 8, which is here. Our next value that we're going to be looking at here is 8 to 16. So I'm going to go over 8 up to 16. And then I'll continue with those pairs. So 12 all the way up to 6. Oh, 24 is up here. Sorry, let's see. 12, 24. It's hard to get these on here. This thing is pretty small. So then I have 16, 32. So up to 16, up to 32. So 16, 32. Ta-da! Beautiful. Okay, and then we're going to continue using equivalent ratios. We're going to see which are the same and different. We're actually going to skip this. Actually, let's do this real quick. So 2 to 3. 2 to 3, so we'd have 2 to 3, 6 to 9, and then 12 to 6, and 18 to 9. So I'm just writing these as ratios as fractions because I know that I can quickly, I can reduce these, I can make them equivalent ratios to see them in a smaller form. So I know that 6 goes into both of these, so I can have 2 to 1. And then this one also can be divided by 3, which is 6 to 3. But then I can also make it a little bit smaller. I can do more of I can go by 3s this time. Actually, let's just start off with the biggest value here. The greatest factor that we have here is 9. So that can also be 2 to 1. And then 6 to 9 we can also do by 3s, which is 2 to 3. Okay. So now that I've done that, either if I've drawn myself a picture, I can see that this, I can do 2 to 3, 2 to 3, 2 to 3. So that one is the same as A to C. Okay, and once I've reduced this into an equivalent fraction, I can see that these are also the same. All right, guys, so this next problem is Ian travels 10 yards on his unicycle every 4 seconds. Based on this ratio, how many seconds does Ian take to travel 25 yards on his unicycle? So right here we have a nice little diagram that's showing us how far he's going in how many seconds. So what we're going to do first is we're going to write down our ratio. We have 10 yards for every 4 seconds. Okay, then I'm going to make myself a nice ratio table. So I have yards to seconds. So 10 yards, 4 seconds. Okay. And knowing what I know, actually, we're going to keep that open. Knowing what I know about ratios is I know that I can make this equivalent. I can make it a little bit more usable. So I know that I can't multiply 10 to get 25, but there is a number within 10 that I can use to get to 25. So I know that 10 and 4 can both be divided by 2. So I'm going to go ahead and divide both by 2. Okay, to make this an equivalent ratio. So 2 on the top, 2 on the bottom to make an equivalent ratio. That will come up with 5 yards for every for every 2 seconds. So now that I have that equivalent ratio, I can go ahead and put it in my ratio table. So I have 5 yards for every 2 seconds. Now that I have a friendly number, I can put in that I need to find 25 yards, right? So what I'm really trying to figure out here is how many seconds is it going to take to get there? Sorry, my ratio table is a little long here. All right. So looking at this, I can see that I'm going to multiply by 5 to get 25. And if I do the same thing down here, I should get an equivalent ratio. So what's 2 times 5? Well, I know that that value is going to be 10. So it'll take Ian 10 seconds to get 25 yards on his unicycle. Okay, so really what I did here is I just played around with equivalent fractions or equivalent ratios. So I divided here by 2 to get a friendly number. I divided here by 2 to get a friendly number. And then we were able to multiply it to find an equivalent ratio that will help us find our missing value. Okay, so we ended up with 10. Okay, there are 2 ways to do it. Either you can do this on a number line, a double number line, where you're counting forward, or you can make halfway marks to find that value. Okay, or you can do it the way that we did, divided by 2 to make a friendly equivalent ratio, and then multiplied by 5 to find that missing value. All right, so a caterer typically uses 40 forks for every 25 knives. So this is the same type of thing that we're going to do here. We're going to first write our ratio. 40 forks for 25 knives. Okay. Then I'm going to draw myself a ratio table. You can do it horizontal or vertical. We'll just go ahead and stick with horizontal for now. So this is forks to knives. Okay, and we know our original one here is going to be 40 to 25. Okay. Now let's try and make this ratio a little bit more friendly by making it an equivalent ratio. So I know that there are some numbers that can both go into 40 and can go into 25, but eventually we know we want to find out 80. We want to find out 80. So I'm going to try and find a number that's compatible with 80. I know that 5 can go both into 40 and 25. So that's what number I'm going to use to make an equivalent ratio. So then I would end up with 8 forks for every 5 knives. So 8 to 5. Now I can go ahead and put that friendly ratio in here, 8 to 5. And then I'm going to see, okay, well, I need to find 80 knives, right? So I need to figure out how many forks I'm going to use. So we're going to do some multiplication division here. So I need to find out what times 5 makes 80. And then I'm going to do that same thing up here. So let's quickly go over here and do 80 divided by 5. So I know 5 goes into 8 one time with a remainder of 3. Bring down my next place value. 5 goes into 30 6 times. 5, 10, 15, 20, 25, 30. And then we have no remainder here. So we do know now that we're going to multiply this by 16. So I'm going to jump 16 spots in my ratio table to get 80. I can do the same thing to make an equivalent ratio up here. So I'll be doing 8 times 16. Whoa, crazy multiplication right there. Let's fix that. Okay, 6 times 8 is 48. 8 times 1 is 8 plus 2 is 12. So I would come up with 128. So I would end up with 128 forks. So now, using multiplication and division in equivalent ratios, I can see that right here I divided by 5 to get a friendly ratio. Then, once I had something that was a little more simple to use, I could use multiplication or division to find an equivalent ratio. So 128 ends up being our final answer. An architect designs a skyscraper with 56 floors. The height of the skyscraper must increase by 45 meters for every 10 floors. Based on this ratio, what is the height planned for the skyscraper? So we're going to try and find meters. We're going to find out how tall something is. So I'm going to go ahead and I'm going to use a vertical ratio table here. Okay, so we have meters to floors. Okay, and it told us off the bat our beginning one is 45 meters for 10 floors. Now again, we're going to try and find a friendly ratio. So we have, let's put this right here. We have 45 meters to 10 floors. What can I divide that by to find a friendly ratio? I know right off the bat when I see a 5 and a 0 at the end of my numbers here that a 5 can go into both of these numbers. So I'm going to divide by 5. So I'm going to count by 5s to get to 45, 5, 10, 15, 20, 25, 30, 35, 40, 45. That's 9 times. And then 5 goes into 10 2 times. Okay, so we'll put 9 to 2. Okay, so that's our equivalent ratio. Okay, now we're going to look and it says, I want to get to 56 floors. So over here, I'm going to put 56. Okay, so in the beginning here, what we did was we divided by 5 to get here, right? I divided by 5 to get this friendly number, right? Now I'm going to try and figure out what can I do with this number? How can I multiply 2 to get 56? And because it's going to be an equivalent ratio, I can do the same thing over here to get this missing value. Okay, trying to pretty up my ratio table as we go here. So we need to find this value here. So the way that I can figure out how many times it's going to go into it is I can do a quick long division problem. So I know that 56 is going to be divided by 2. 2 goes into 5 2 times. The remainder of 1, bring down your next place value. 2 goes into 16 8 times with no remainder. So I look and I'm going to see this can be multiplied by 28 to get 56. So that means I can do the same thing over here. I can do 9 times 28 to get the missing value. So that's going to be 72. Oops, sorry guys. And then 9 times 2 is 18. Plus 7 is 25. So we are going to end up with 252 here. Let me erase this guy here. So we're going to end up with 252. That is our final answer, what we were looking to solve. So we know that it's going to be 252 meters tall. Okay, so again, what we're going to do for the second half of this lesson is we are going to try and find a friendly equivalent ratio, and then we can find the missing piece by making another equivalent ratio. Okay. If you have any questions, please let me know. Message me on Canvas, or we can hop on a meet and work through some of these problems.